15 minutes only because I want to discuss one okay, one example because next week is your, I think Thursday is your test 2. So okay, I hope, okay, satu lagi I have made a mistake regarding project submission. Actually today is the deadline. Kan? Was falsely stated third, what's about 4 4 June Thursday. Betul ke? Nampak tak? Because I have problem with calendar everything. So okay, tak apalah because I make mistake. So you all submit tomorrow je lah. Okay tak?
Okay,
Alright.
doktor.
Sebab because betul ke saya tersilap tu saya buat Khamis ke you all yang pandai-pandai ni?
Memang Khamis doktor.
Betul Betul Saya buat, I put Khamis 4 Jun
Yes.
Okay, nanti saya double check. Saya ni suka percaya je kat sudah. You suka memainkan saya kan? Okay, tak apa. So okay, now I don't want to take your time longer. So I think we just try to finish by before 1:30 lah kan. Okay, now I start sharing my screen. Okay, so nampak tak saya dah get ready with this. Okay, I hope all of you holding your lecture note in front of you. So okay, last time I have shared this example, right? So together with the YouTube video, okay? Kalau you tak dengar my voice, better tell me earlier tau. Nanti I don't want to talk alone. Okay, so tak ada lagi apa-apa. So semua dengar kan? Alright, thanks Siti. So can I skip this example? I hope all of you understand. Faham ke tak this example? Guys. Apa no comment?
Macam tak faham.
Macam tak faham? Okay. Betul ke saja ni buat tak faham? Okay, now tak apa. Sebab memang tak faham. Okay, now I draw a car A car. So I'm not a good artist tapi I try my best. So pakai this one. Okay, this is your car. Okay, and then kan masa kecil this is the way I draw a car. Okay, tak apalah. Jangan gelak Okay, this is your tire. So your car moving in this direction. Okay, so with the speed of 80 kilometer. Okay, so we assume the direction, okay, the direction of the car is in this direction and then the wind blow the other direction. Agree tak? Opposite direction, kan? Agree or not? Meaning that the air flow over your outside car in this direction. Okay? Now, and then 80 kilometer applied also to this because we assume the velocity is the same with the airflow velocity. The car speed and the airflow velocity is the same. So now this is your windshield. Tahu tak windshield apa? Yeah, cermin depan, not the side.
Oh, depan.
Depan, windshield, the front the front glass or screen. Windshield lah, kita panggil windshield. Okay, so now let me draw another. So katalah if you look the windshield from this angle. Yeah, from this angle. Okay, so how it look like? So dia maybe look like this, right? Betul tak? You look front view. Kan? Betul? So
Betul,
where is the
front
driver?
view.
Okay, this is the driver kan? kalau you tengok from the front view. So this is the what the car apa ni, what we call it, the engine. Pandai tak saya lukis? Kan the engine, and then this the tire. Betul? So this is the windshield. This is your windshield. Okay, now the wind flow over this windshield. Understand or not? Because when we move, the car is moving, so the airflow, the air flows over the windshield, kan? Due to the moving car. So now, this airflow, what is the value of this airflow? Still the same, 80 kilometer per hour. Okay. So now inside the car. So from this question, it mentions that the car having problem with the what? What is the problem of this car? Ada something to do with the fogging issue. Okay, the outside air, ambient, and then the average velocity windshield, while the ambient temperature inside the automobile is 25 degrees C. Determine the value of the convection heat transfer coefficient, that is H, for the warm air blowing over the inner surface. Okay, to prevent the ice from bukan to prevent, to make the ice melt, so that the fogging, apa yang fogging tu maksudnya kabus kan, kalau kat depan cermin kita kabus tak nampak kan. So that is the purpose lah of the heater at the dashboard tu. So now you all semua ada kereta kan, you kan orang kaya semua kan. So kalau if we view the car from the inside of the car, now go, okay, this is your sekejap pula salah. This is your windshield from inside of the car, yeah. So where is the driver? This is the driver. Betul? Kita orang Malaysia kan? We are right hand side driver. Sarawak pun. Okay, kita Malaysia. Sarawak pun sama lah, kanan amboi. So now, you duduk negara mana? So now in front, okay, this is your dashboard kan? And then all the events, the heater punya, the heater is located in front and on the dashboard lah, sort of kan. And then the wind will be blown like this, right? Agree or not? If you look from the side view, if I cut this plane, yeah, so it will look like this. Okay, this is inner, this is outer. Okay, outer, this one. This is outer, this is inner. So the inner is what? From the dashboard. And then the outer from outside air. Betul? 80 kilometer per hour. This one I don't know the velocity. Understand or not? Dekat inner, because we need this to blow the air so that the hot air will flow over the inner, so that can remove or eliminate the fogging, the fog. Kan? You mestilah blow the hot air so that this one get warmer, so the condensation ataupun embun tu, the fog tu will condensate. Faham tak? But you don't know the V. We don't need the V. Tapi saya tercakap. Okay, I don't want to talk about V. Okay, nanti confused. Okay? But this one is actually has a value of V. But the problem does not provide that value. Boleh? Boleh tak Siti? Faham tak? Yang lain-lain Muhaimin, janganlah cuba. You kena faham. Jangan cuba. Ni cuba-cuba ni. Tak boleh cuba-cuba. Dia kena seriously. Yes, I understand. Okay. So this is your side. Bukan the side. When I cut in the middle of the windshield. So this is the inner. Katalah sebab saya sketch it vertical kan, very straight. What we call arrangement. Sebenarnya look like this kan? Betul? Betul tak? Agree or not? Inner and outer. And then this is the wind from the outside due to the moving car. 80 kilometer per hour. And then this one is from the inside blower. So the warm air, okay, to eliminate or to condensate the water vapor. Okay. So now you are asked to determine the H of the inside air. Betul tak? Let me go back. So what is the question? The convective heat transfer coefficient over the inner surface of the windshield. Okay, meaning that you need to know the H of the inside and outside as well lah. Yeah. So this one is actually the arrangement is like this. Okay, but they sketch like this lah kan, tak apa. I hope you understand lah. You can imagine how the arrangement. So now, to do that, to find H, what you should do, you have to find H. Before you find H, you have to determine Reynolds number, correct? That is velocity times L times nu. So for this case, what is your medium? Agak-agak yang mana? The mirror or the windshield. Okay, because windshield meaning that the effective heat transfer happen due to the outside air and inner air, right? Okay, so now this is your windshield. Based on the question, the length of the windshield is given as 0.5 meters. Am I correct? Okay, good, great. So now that is equal to L. Okay, because we want to determine Reynolds number. So you must have velocity, and the velocity S is 80 kilometer per hour. Because we are considering the outside air first, because we know the V. Because I don't know the inside air's velocity. That's why we consider the outside air first. So based on this information, and one more thing, so we need to know what are the thermal properties, okay, to calculate Reynolds number. You need to know the nu, and then the Prandtl number to determine the Nusselt number, and then another one is the K values of the air, okay. But before that, to determine those properties, you must please. Yes, that's our assumption. We assume constant velocity. That's our assumption. Okay? Boleh. You have to specify lah. Okay, my assumption the velocity is constant throughout the for the entire windshield. Okay? Okay, now to obtain the thermal properties of the air, it is based on the film temperature. Do you still what is film temperature? Surface plus air temperature, ambient temperature divided by 2. Am I correct? So the film temperature for this case, if we refer to this example, can you see this? Negative 20 plus 0 divided by 2, that is negative 10. Betul ke? Okay, meaning that the temperature of this surface, the outside surface, the surface temperature is outside 0, and then the ambient is 30, not 30, 20 negative if I'm not mistaken. Negative 20. So negative 20. Okay, so based on this, can you see jauhnya. Okay. This is the outside air. Kita buat terbalik lah And then the thickness of the windshield is also given. Okay, based on that information, you can obtain the thermal properties from table A15. Okay, where is table A15? This is table A13, so A14, A15. Okay, now I don't know why saya highlight this. Okay, I want to, sorry. Okay, negative 10, right? So this is the negative 10. So all the K, saya besarkan Nampak tak, understand tak? The rest, ada Syafiq tak in this class, today's class?
Ya, ada.
Ada, okay, besar datuk sangat ni. Patutlah, okay, let me use very thin. Okay, this one. Okay, Syafiq ada ya, bagus. Okay, this is the thermal properties. So based on this, you can obtain your K and then the new and also the Prandtl number. We will use this to determine H. Okay, based on that, so this is your Reynolds number. That is 8.875 times 10 to the power of 5. Meaning that this value is between the range, within the range of this, right? So we can say it that this condition ataupun the flow type is a combined laminar and turbulent. Okay, because of that, you can select the right suitable Nusselt number. Okay, boleh faham tak ni? After knowing, after determining your Reynolds number, you must select a suitable Nusselt number. Boleh Yang tu faham kan? This will be tested in your test too Hopefully So now, tak menyaut. Mesti pergi makan tengah hari kan? So okay, so after, can you see the subscript zero, not zero, O. O meaning the outside. Bukan O, no. O is outside. Okay? Boleh tak? So saya tak dengar suara satu sen pun kat sini.
Boleh.
Boleh,
Siapa
Kak.
yang bersuara tu? Geram ni tengah makan apa?
Dah.
Tempe.
Aiman.
Aiman. Bagus. Ya Kak Aiman, okey. Ni Aiman kisah ke tak kisah? Ni Aiman yang kisah kan? Sebab tu dia menyaut. So okay, now can you see the O and then the I? I for the inside, O for the outside. And then this one, infinity is for ambient temperature. Okay, you nampak tak? This apa formula tak ada in this chapter, right? So this one comes from where? Do you still remember chapter 2? Chapter 2 or chapter 3? Thermal resistor network topic.
Ingat lah doktor.
Not quite remember.
Tak remember the
Tak
equation.
remember. Ya ke? Aduhai. Penat je belajar tak ingat kejap So where is it? Okay. Okay, this is just to recall your memory kan. You all kan temporary memory loss Okay. This is your windshield. Okay, windshield. I'll make it vertical so that easy So saya ni because saya lukis tak betul ni sebab now let me okay, arrange my iPad. Okay, now. So, okay. Wait. This is your outside. This is inside. Okay. So, the temperature here, T outside is 0 degrees C, right? And then the ambient temperature is negative 25 degrees C. And the inside air temperature, salah, saya guna term yang betul. Wait. Infinity I is 25. Agree? I don't know the surface temperature. I don't know. I only know maybe the profile of the temperature is like this. Yeah? Okay. 25. So this is the direction of the heat. This is 25. So thermal resistor network. Do you still remember when I sketched like this? This is R. Baru ingat kan? So this is R for the window and no window windshield, and then this is R for the outside. Remember? And then heat flux or heat for this is equal for each layer. Okay, kan? So now can you see for this, this one, I can straight away find my Q. Why? Because I have surface temperature, ambient temperature, and then, but you don't know the H value lah, right? Okay, so you cannot. Okay, write properly. So this one, the Q is actually what? H outside. Okay, and then surface area no need because this is heat flux, and then T surface outside minus T infinity outside is equal to saya selalu lupa formula ni. K T, this one is T surface inside. Betul tak? This one inside, this is outside, right? So Ts inside minus T S outside divide by delta X. This is delta X. Okay, the thickness of the windshield is equal to, for the inside, H T. Apa saya lagi? Faham tak yang ini? Yang ini faham ke tak? I ask you. Understand or not?
Faham.
Faham
Ni yang
Okay,
chapter 2 kan, Doktor?
Chapter 3 I think, chapter 3. Kan saya pergi chapter 3 lepas tu patah balik ke chapter 2, ingat tak? Tapi yelah, so this is thermal resistor network lah. Okay, itu maksud dia. Okay, thanks to understand it. Okay, kejap ya. Surface in. Okay, semua ni similar. Now, our purpose is to determine H for each layer. This one and in and this one also I want to know. But I can find this using this technique. Nasut number ni. Can you see this? And then based on this, you obtain your H for the outside air. Tahu kan how to get this? Guys,
Okay.
tahu kan?
Okay.
Okay, pandai. Good. So now nak cepat kan? Saya janji ke 1.5. Okay, now. Then, you already know this H. Okay, you know surface and you know everything. You can calculate your Q. Your Q. Okay, saya tak ikut dia punya method tau. I use my own method. So, so the Q is H outside T. Okay, so H just now from your calculation is 1.75. T surface 0, outside air negative 20, and okay, I don't know the answer. So what is the answer? This one sebab I don't use the way the book use. Okay, let me check. 20 times 51.75, 1035. So what is the unit? Watt per meter square, because we are considering the heat flux, no A. Can you see there is no A term? Yeah, surface area. So, and just now I've told you that Q inside is equal to Q of the windshield is equal to Q of the outside air. So based on this value, can help you to find H at the inside. Betul tak? Because, sebab apa? This actually H inside T TS equals 1035 watt per square meter. But you don't know this value. How to find that value? That is why Q of the windshield equal Q of the outside air. Okay, you know this value 1035, the Q of the windshield, because this is conduction. So K, T surface in minus T surface outside divide by delta X. From here, you can determine the surface area of the inner surface, bukan area, the inner surface temperature of the windshield. Boleh tak yang ni? Mana ke dia punya
Boleh ada.
solution? Boleh kan? But now dia to try to shortcut and simplify. That is why dia just macam myself just now just do one by one, step by step. Okay, but will give the same result. Okay, so now can you see that the solution does not solve for T surface area, the inner surface temperature, area of the windshield. Dia straight away obtain the H sebab dia do like this. Boleh understand The term have been cancelled out everything so that only the known values or terms are used to determine the H of the inside air. Okay, itu for that example. Any question before we proceed to another example? Dah faham dah sikit Siti? Cepet pula, aduh dia ni. Confident lah sikit. Kan? Pandai. Tahu takut. Okay, saya laju. Although quite fast, but I think the topic is not too difficult to understand. That the key point, yeah. So it's quite easy, but you have to understand the question. You know the theory, but you don't understand the question pun problem juga sebenarnya, So okay, for this case, apa ni? You don't understand, right? And then you can see that the airflow from this direction, and then this is the plastic sheet, and then the sheet moving in this direction, and then what is this? The length of the sheet, the width of the sheet are given. And then the thickness of the sheet also given. But do you know how to use all the data to solve the problem? Itu the reason, that's the only problem lah students always experience. Betul ke tak? Ke saya saja je mereka cerita? Tak kan? Okay, pandai Siti. Baik. Please lah menyaut sebab saya sejak I'm talking alone tau. Kesian tau saya ni. Dah lah terkejar-kejar dengan meeting tadi. Okay. Okay, now okay. Thank you so much for your cooperation. Okay, now ni nampak tak 95 degrees C is the surface temperature. Surface temperature of the plastic sheet. Okay? So if I write properly, this is surface temperature of the plastic sheet. And then this is, the length. Why this the length? Because the direction is in this direction. Can you still remember that I have a flat plate and then the direction of the airflow is from this direction? So the length is this. Betul? Remember the theory? Same goes here. Itulah tak apa buat revision. Minggu depan dah nak test. So meaning that this is the question try to trick you. Okay, maybe some student will use this as the L value and someone yang bijak, intelligent will use this as the L value. to identify which values are ataupun which is L, yeah. So you have to find where is the airflow because the L and the airflow the direction is parallel. Boleh So parallel kalau this way meaning that the L is this direction. This is the L. Okay. So why we need to know the L? Because we want to determine the Reynolds number. The Reynolds number is velocity times L divided by nu. So the L must be correct. Yeah. So the question wants us to determine the rate of heat transfer from the plastic sheet to air by forced convection and radiation. Okay, great. So meaning that before this, we just consider convection. But for this problem, we have to include the radiation heat transfer mode as well. So meaning that determine the rate, you want to determine the Q of both. Q due to the convection plus Q due to the radiation. Okay, so you have to determine or calculate those Q one at a time lah, and then you add them both. Okay, but for Q convection, we start with the Q convection first. So your Q convection, okay, we will use what? H, right? And then A of the sheet divided by not times T surface minus T of the air. Okay, now surface is hotter than the air temperature. That is why we subtract Ts and first. Ts subtract T infinity or T air, temperature of the air. So now to calculate Q convection, you first must calculate your H. To calculate your H, you must first calculate your Reynolds number. After knowing your Reynolds number values and the range of this value between what to what, so you can determine the flow type, whether it is laminar or turbulent. Why we need to know this? Because laminar will use different formula, turbulent will use different formula of Nusselt number. Okay, that is the purpose why we need to determine the Reynolds number to select, to select a suitable Nusselt number formula. Okay, so now let us determine the Reynolds number first. Okay, this is what I did tadi sambil-sambil meeting saya cuba buat kerja ni. So, can you see that this is your sheet, kan? So, this is the way of the direction of the sheet. But this is the direction of the air. We have to consider air. And then this is the length. So, the Reynolds number, what is the formula of Reynolds number?
VL over mu.
Pandai, pandai. Siapa yang cakap tu? Siapa? Pandai dia tukar
Mazuki.
menyamar. Jadi orang lain. Mazuki Maktum kan? Saya ingat bapak dia. Sebab bapak dia nama unik. Okay. So, okay. Senang nak ingat macam tu. So now, but before that, you have to evaluate the properties of the air at the film number. Betul tak? This is your film number. Film number. Film temperature. Ya Allah. So, film temperature surface is 95 plus the air temperature is 25 divided by 2. So your film temperature is apa? Saya tengok soalan ni lah. Apa dia punya ni? 60 degrees Celsius. Oh, quite easy lah, 60 degrees Celsius. So to determine all the K, nu and Prandtl number, you must refer to table A15 and evaluate it at film temperature of berapa tadi? 60. Which is, mana 60? Okay, kuning lah senang. And then 60, sorry, this is 60 . Okay. So this is your parental number. This is your K. We need the K to be used in your Nusselt number formula. And then this is your new. And then this is your parental number. We need these three properties to solve for Reynolds number and Nusselt number. So to determine your Nusselt number by using this, okay, you have to identify what is the L for this medium. So as what I've told you, L and the airflow must be parallel. Okay, this is your plate. So L is parallel with the airflow. Based on this, we can see that this is the flow and L is this. Okay, so 1.2. So 1.2 times the velocity of the air times the nu of the air at film temperature. This is the value. Okay, this is the value. So from there, we can say it, this is combination ke or laminar flow? Laminar flow, right? Because the value is below. Below ke? Below 1 to the power of
Below 5.
below kan? Okay. So because of that, this is the laminar flow. Okay, now saya nak, sebab saya tengok macam ada you all macam tak berapa faham. Lepas dapat Reynolds number tu nak buat apa kan? Okay, now.
Betul.
Okay, so first of all, this is constant surface temperature or constant heat flux based on this problem? Constant surface temperature, right?
Yes.
Yes.
Constant surface temperature. So we will use constant surface temperature formula on a hot flat plate. Okay. Dia tak nampak sekejap ya. Constant heat flux, constant temperature. Where is, okay, this one. Okay, uniform temperature. Okay, and then this one is for local and another one for average. We will look for the average. Okay, for the entire flat plate, we must refer to the average. If we are looking at certain or specific distance from the leading edge, we will look local formula. For this case, average, because we want to know the entire flat plate. So this is the formula 7 to 1. Or this one for yang turbulent ni 7 to 2 For this problem, we will use 721. That is why nanti during your bila you do analysis, please include the equation number. Ya, saya ulang-ulang banyak kali equation number 722 and this one tadi. Okay, 722. This is 7. Betul ke 722? Check lah balik nanti. Yeah. Correct or not? Equation 722. Okay. So you will use this. Can you see that you need to include your parental? Yeah. That is why we need the parental number and also the K. So you rearrange this. The purpose is to get the H. And then this is your H. Value ke? Dia dah kira H? Not yet. Okay, this is the H value. Okay, you rearrange and you get your H value. The H value is the H of the outside air. This one. This one. Okay, this H. Okay, so for the radiation, okay, this is the H. For the radiation, you will use this formula. Okay, and then the emissivity of the sheet is given and this is your answer for the radiation and you add both up and this is your total heat transfer rate from the sheet to the surroundings. Senang ke susah? Ke mengantuk? Saya yang mengantuk. Saya mengajar, saya mengantuk. Apa ni? Okay, tak adalah. Okay, now last before we stop. I have prepared your attendance juga tau. Okay.
Doktor.
Ya, saya.
Yang lokal tak lokal tu macam mana?
Local tak local. Okay, like this. If you have let's say you have a flat plate, sebab that equation is for the flat plate kan? This is your flat. Apa ni jadi macam ni? Okay, kejap. Okay lah, saya lukis pakai biasa je lah. Sekejap Okay, this is your flat plate. Okay, and then this is your x equal 0. And then this x equal L. So when we are talking about average, meaning that the Reynolds number is for the entire flat plate. This one is R average. Local meaning that you want to know at certain location. Maybe at x equal 0.5. Okay, this. So this one we call it as Reynolds local. So the formula is the velocity times not x, but not L, but x. We want to know at certain location. Divide by nu. The rest the same, only the location. Dah, boleh faham yang tu?
Boleh.
Okay, so when you, after you know the Reynolds number at this particular x location, and then the Nusselt number is the Nusselt number at that particular x lah. That is why you subscript x. Okay, the subscript x meaning you are evaluating the h at a specific position. Apa ni, on ataupun over the flat plate tu lah. Ya, boleh Senang je nak cerita yang tu. Okay. Okay, boleh faham Saya senang cerita tapi yang penting you faham ke tak? You understand or not? Ya, siapa lain cakap faham tu macam ngantuk. Okay, tak apa. Saya nak kena, saya janji. Dekat 1.5, ya Allah, kita minit. Okay. Now, this is the last part of this chapter. Okay, to find the temperature of the plastic sheet, at the end of the cooling section, we need to know the mass of the plastic rolling out per unit time, which is determined from, in this question, let us go back to the original question. Okay. Sekejap, saya tengah fikir. Okay, this is your sheet tadi, sheet yang very long sheet. Salah pakai. Sorry. So sorry sebab saya ni ada gangguan dekat sini tu. Saya jadi slow lah ni, aduhai. Jangan ganggu saya di sini please. Okay, this is your sheet, your plastic sheet, and then let's say sekejap saya baca balik, determine the rate and then the temperature of the plastic sheet at the end of the cooling section. Okay, let's say this is the cooling section on this part. Yeah. So what is the temperature after passing the cooling section? That what the question wants us to find out. The temperature after the sheet passing pass the cooling section. Cooling kan, dia nak cool down the plastic sheet. Boleh faham tak yang tu? Saya go back to this part. Boleh faham ke tak?
Boleh Doktor.
Boleh? Ya. Macam ni boleh faham? Saya pula yang tak faham ni. Bagusnya. Siapa yang cakap boleh tu? Siapa Syafiq, tak tipu You jangan guna nama orang lain. Betul nama you Okay. Okay, sebab apa you faham? So actually you have a pipe. Okay, this is your pipe. At least macam you ada satu pipe. Biasa lukis guna different Okay, let's say saya try to make it slowly and steadily. Okay, this is let's say a pipe. Pipe like this. Okay. And then there is something comes flow in and flow out. Okay. So flow in at temperature T1. Usually we put it as T1 kan. And then it exit the pipe at T2. Still remember this is thermodynamics. And then the flow flowing into the pipe with certain flow rate. Some other mass flow rate, volume flow rate, everything can be done. Okay, can be used. Okay, with certain mass flow rate entering the pipe and exiting the pipe. So now the question is actually want you to determine the temperature when the fluid exiting the pipe. Okay, based on energy apa ni you belajar during your thermodynamics. To find the Q inside the pipe. This is not convection tau. Kalau convection HA time delta T. But for this case is M CP T final minus T initial. Still remember this tak?
Yes.
Now we
Ingat.
Yes, Doctor. Yes,
Yeah.
Doctor.
Dia transfer dia.
Sajalah. Okay. Then yeah. Okay, sebab ni tengah makan tengah habis. Saya tak makan lagi. Okay, dekat nak habis dah ni. Now, this we assume the fluid is the plastic sheet. Enter the cooling section and then exiting the cooling section. Itu saja sebenarnya. Yeah. So, we know the M dot and then we know ke M dot. So, the M dot can be calculated using this formula. Okay, the plastic sheet formula, the density of the plastic, the cross sectional, because the plastic tu kan dia for part segi kan. So this is the cross sectional of the plastic surface area, this one. And then the volume, bukan volume, the velocity of the conveyor, that convey the plastic lah, Okay, so you will get this, the mass flow rate, and then you substitute and you will get the temperature passes the cooling section. Okay. Kalau tak faham, try to understand again because I have provide you with the book and also the lecture note and also the YouTube. So I hope lah you can understand that. If you have problems, okay, do you want me to give you some problems?
Some problem for this question.
Problems untuk meaning that for test to preparation. Bukan saya bagi soalan test. Meaning that you must maksudnya kena buat soalan lah. You kena buat exercise. You have to do a lot of exercises lah.
Exercise with
Solutions.
solution, I think okay. We can learn from that.
Amboi. Tapi bukan soalannya exactly like test tau. Saya tak nak bagi soalan macam tu. Just give something and that to strengthen your understanding. Suka hati. Okay, I will give something that can strengthen your understanding lah on this topic. Yeah? Okay. So, alright. Now, we have to stop now because, but before that, I have to share the attendance Google Sheet, Google Form. Kejap. Saya dah tak share dah kan? Okay, now I share another thing, the link. Semua okay hari ini? Sementara saya kalau cari saya memang kena berbual-bual untuk saya nak bagi saya yang tak panik kan. Semua okay hari ini?
Okay, Doktor.
Alhamdulillah, Doktor.
Apa dia? Okay. Itulah siapa suruh belajar. Baik tak belajar lagi sebenarnya. Saya nak tanya. Saya ada terbaca tentang UTM Confession.
UTM Confession.
Tentang you all rajin ke yang hantar benda tu? Tak kan?
Selalu baca je, tak hantar.
Selalu baca.
Itulah sebab kebanyakannya budak SME yang buat kerja tu.
SME.
Mechanical lah.
Oh.
School of Mechanical Engineering. Kan? So, okey lah. Saya macam, oh, okey. Tak apalah, baca je lah kan. Saya tak nak cakap apa-apa lah, no comment. So, okay. Guys, saya dah share the link. I hope after this, you boleh dismiss lah. Okay? Tak ada question lain Project, everything. Project saya sebenarnya bagi you free to think, to use your own creativity so that sebab dia ada rubrics untuk evaluate that. Kalau saya dah beritahu, saya tak boleh evaluate you punya creativity. Okay? Pandai. Good. So, okay, ada soalan lain?
Tak ada.
Tak ada, doktor.
Ada tak siapa in this class yang no member? No group members? Tak ada kan? Okay, Ahmad Iyad, you section 2 ke section 6?
Saya initially section 2 and then got transferred to section 6. Tak tahu?
Okay. Sebab saya pun macam dah confused. Okay, you section 6 sekarang
Okay.
Section 2? Bukan section 2?
Awal-awal patutnya section 2 lah. Lepas tu kan ada time tu ada setengah student transfer.
Saya check balik macam mana section 2 balik. Tak apa sebab dia dah
kau balik
bercampur-campur. Saya dah pening kepala dah. Tak apalah, apa-apa pun still dalam kelas saya kan.
So lastly kena
You punya group
section
member siapa? Itulah
Amirul
nanti saya
Hakimi.
check balik. Saya takut saya salah.
Amirul Hakimi.
Itu Amirul section mana?
Saya section 6.
Oh, so Ahmad Iyad sebab section 6 lah you berkawan dengan Amirul lah. Maksudnya group dengan Amirul lah kan? Okay, tak apa nanti. Tak apalah kalau dah tersilap sikit pun tak apa. Still in my class lah. Cuma saya nak double check. Okay?
Okay, betul.
Okay. Siapa-siapa yang dah take your attendance boleh itulah exit. Leave the meeting.
Thank you, doktor.
Okay,
Thank you, doktor.
Doktor.
Thank you, doctor.
Thank you.
Makan.
Thank you,